Hi, it's Jen Simpson. I'm going to be talking through my lesson on a 5th grade long division unit. This is lesson 3 of 4 or 5 lessons on this unit. The students should be very familiar with division, particularly 1-digit divisors, and the focus of this lesson will be 1-digit and 2-digit divisors using long division. Because I'm not in an internship right now, I don't have access to a classroom, and I'm not in America, so it's quite difficult to find the proper tools I need. So I won't be demonstrating as much as I had hoped to, but hopefully my explanation will be valid enough so that you can understand how the lesson will be set up and how the students will be engaged, particularly using like a problem-solving approach. So to begin, the students will be seated on the floor, kind of semicircle. I'll be either in a chair or a stool at eye level. That way I'm able to monitor the students and really work with them, hopefully in even a one-on-one or small group setting. Right away, we're going to start out with a fun activity called the wall divide. It's just a really stimulating mental math division game. The students should be able to solve these problems without the use of paper or their whiteboards. If I notice some of the kids give me puzzled looks, at the end of the game, I'll ask some of the stronger students to demonstrate how they solved some problems. For example, 16 divided by 4. They can use any representation they want to solve the problem and to demonstrate, because the students should already have background knowledge on the standard algorithm for 1-digit divisors, as well as using model and symbol representations to solve these problems. After the game, I'm going to go straight into the learning target, which is, it's going to be on the board. It's going to be much better than this. I think just having like a magnetic learning target with whatever it is. But I can divide 3- and 4-digit numbers by 1- or 2-digit divisors, and we're going to read that together. And we're going to pay attention to divisors, and I'm going to ask the kids, and this should be a review. I'm going to say, okay, what is a divisor? Who can tell me which number is a divisor? And I'll write a problem, like, for example, 405 divided by 5. I'll say, okay, in this problem, you can see what is the divisor. And hopefully they'll say the divisor is the number that is dividing into the bigger number, which is right here. So you divide into the divisor. And I'll say, okay, so the bigger number, does that have a name? And then hopefully, this should be reviewed, they'll say it's the dividend, because divide, dividend. And we'll write that. We'll probably have a student write this. And we also would have like a math vocabulary wall that this would go up onto. So there you go. Whoops. Divisor, dividend. Right away then, you say, okay, let's get into groups of 2 or 3. You 2, you 3, however it's arranged. And I'm going to post a problem. Let me find the problem. I'll read it. It's much easier to read. So on the board, I'll have a problem, like hopefully if the interactive board says, okay, this comes from the book, by the way. The bag has 783 jelly beans, and Eileen and her 4 friends want to share them equally. How many jelly beans will Eileen and each of her friends get? And I'll say, okay, so what is some information we need to know? What is the divisor? And it's kind of tricky because Eileen and her 4 friends, and some of the kids might automatically say, well, it's 4 because 4 friends. And then other kids might say, no, wait, like Eileen. So we'll decide as a class, okay? The divisor, I'm going to be writing this on the board. Divisor is 5 because we have Eileen and 1, 2, 3, 4 friends. And what is the dividend? So the dividend, how many jelly beans are there? 783. I say, okay. In groups, you're going to work together and you're going to solve this however you want. And you have 3 minutes. Go. And the kids are going to be solving the problems, working together. And, beforehand, I forgot to mention, they're going to be given their individual whiteboards. So they do have individual whiteboards, as well as graph paper, base 10 pieces, and paper plates, if they need those. Some sort of manipulatives. Sorry about that. And at this point, like this component of the lesson, like the students are expected to have prior knowledge of standard algorithm for one-digit divisors. Base 10 blocks were introduced to solve division problems in the previous lesson through direct teacher modeling. At the same time, students have already developed student-invented strategies, so ones from the book that I used, as well as strategies that they've come up with on their own. And so they should know how to do this. This is just a very quick review. At the end of the time, I notice the kids are done, or when the standout runs out, I'll say, okay, you guys, you share. How did you solve this problem? And hopefully by then the kids are able to demonstrate what they have done, how they solved this problem. The next one, I'm going to say, okay, number 2, you got another problem. And the question is, Jumbo the elephant loves peanuts. His trainer has 625 peanuts. If he gives Jumbo 20 peanuts each day, how many days will the peanuts last? And this time I'm going to ask the kids, okay, you solve this one. You figure out what is the dividend, what is the divisor. Now, here's the trick. You need to solve it using a different strategy. If you use base 10 blocks for the first question, can you use base 10 blocks again? No, you can't. And hopefully the kids will have been paying attention to how their classmates explained the previous problem. And that was, okay, I noticed, I'm learning from modeling. And at the end, again, I'm going to have, maybe different groups share their strategies, and hopefully 4 different strategies will be modeled. And these strategies have already been introduced in the 2 previous lessons. And those strategies are using base 10 blocks and a sharing process, that's one, the missing factor approach, the cluster approach, and the standard algorithm for division. That's using symbolic representation. And if I notice some of the groups haven't demonstrated this, then that's where the teacher modeling will come into. And I'll reintroduce the learning, because it's very important that they don't have to always use these, but they do need to be aware that there is more than one way of solving a problem, and depending on the problem, certain methods might be more useful. With that, we're going to go into the whole group instruction for 2-digit divisors. I'm going to introduce a story problem, and if you can read it, this will be on the board. It says, blank's mom needs to make blank cupcakes for the school fundraiser. A cupcake tray holds blank cupcakes. How many cupcake trays will be used to make all the cupcakes? And then we're gonna fill in, like, okay, so let's do John's. Okay, John's mom. Okay, needs how many cupcakes? And the kids are gonna blurt out a random number. In this case, I've already written down 838. It's a lot of cupcakes. Okay, and a cupcake tray holds how many cupcakes? And I've already, okay, 14. Okay, 14, they tell me. Now, what is the question asking us? What is the question asking us? Okay, yes. Okay, how many cupcake trays, will it have to be used to make all the cupcakes? Okay, so how many cupcake trays? That's what we want to know. What is the divisor? Again, we're reviewing the vocabulary. The divisor. Who can tell me what the divisor is? Oh, it's a number that's dividing into the bigger number. The divisor is 14. And what is the dividend? 830. And then I'm going to ask the kids, okay, who knows how to set this problem up? It's the same way we set up a 1-digit divisor. Who can show me how to set the 2-digit divisor? Anyone? And then see, this is also kind of a way of me diagnosing their prior knowledge or what they do know. Hopefully they'll be able to set it up like this. Yep. Oh, where does it go? Okay. And I'm going to tell them, okay, you're right. We are going to be using the bring down method. I'm going to introduce you as the bring down method for solving these kind of problems. We're not going to use base 10 blocks. We're only going to be using our whiteboards and our markers to solve this problem. And then that's when I will get into the teacher-led demonstration. Okay, we're going to solve a standard algorithm using the bring down method. Before, let's look at our example. Okay, for 830 divided by 14 from our sample problem, we're going to go ahead and write our steps down the side. That would be divide, multiply, subtract, bring down, and start over. This time each student will have their own whiteboard and they're going to be writing the steps down along with me. And we'll be doing this together. They have the place value columns. That way the students don't lose track of where they write their numbers, and that will avoid the error. Okay, so that is step 1. Step 2 is I'm going to ask the students whether they know their answer will be in the thousands, the hundreds, the tens, or the ones. And we're going to be using the doubling sidebar chart to find this out, and hopefully students will be shouting out, okay, hundreds! Okay, and at that point, all right, let's see. Okay, hundreds. Okay, let's try 14 times 100. Oh, what do we get? 14. That's way too big because our dividend is only 138. And then they'll say, okay, tens. All right, great, yay. So we'll be making the doubling column. Okay, 14 times 10 is 140. We'll keep going. Hopefully kids will be shouting out answers like, and this is a way of the estimation, using estimation to solve these problems. Okay, so let's go with 30 times 40. Okay, that's 420. Any guesses? Maybe a student will guess 50. Okay, 50 times 14. Oh, that's 700. That's still too low. 80. Oh, 80. That's way too high. And by, once we go, more guesses, we'll come to realize that 50 is the correct guess because it is, because 60 is a little bit too high. And I will ask the students, okay, can you see how knowing the products of 10 through 80 can help you solve this problem? And say, okay, because we're using estimation to help us solve the problem. And it's really good to avoid using goes into language. That's, again, how I was taught what goes into, but it's kind of abstract and the kids don't really understand the concept of what it goes into. That's why they need to see the doubling bar chart so they can really picture the place values. The next step, let's see. Okay, so we're going to be using the standard algorithm, and we're going to be saying, okay, so let's, I wrote these all at once, but we have our, we have our steps, and using the standard algorithm, we're first going to take, we know that 5 is the correct number in our tens place. Okay, and we're going to multiply 5 multiplied by 14, and from our doublings chart we learned that's 70. And then we go to subtract. We take 3 minus 0, okay, is 3. 8 take away 7 is 1. Then we're going to bring down our next step. We bring down the 8, and I drew an arrow so they could see that. We bring down the 8. Okay, for step 4, we're going to again use our doubling sidebar chart to find out what goes in the ones place. In this case, we already know from the previous step that 10 multiplied by 14 equals 140, and that is too high. So we're definitely going to have to go lower. And in order for them to realize it's in the ones place, and if it's in the ones place, can it be higher than 9? And then hopefully they'll say no, it can't. So we know it's a number between 1 and 9. And that's a really good way to check to see if your answer is correct. Because look at, we're looking at the ones place, 1 through 9, 1-digit number. In this case, we're gonna, okay, let's make some guesses. How about 8 times 14? Okay, that's 112. We're getting really close. Oh, okay, someone guessed 9 times 14. Let's look at our board. Who can do that quickly? Oh, you got it. What is it? 126. Oh, is 126 closer? Yes, it is. In that case, we're going to write in the ones place, 9 in the ones place, and then we're going to follow our steps. We multiply. 9 multiplied by 14 we got is 126. Subtract. Again, I'm going to carry down the column so we don't get our numbers mixed up. Okay, 8 take away 6 is 2. 3 take away 2 is 1. And at this point, the kids will be calling out the answers, and leave that even in blank. Okay, we get 12. For part 5, since there are no more arrows to draw down, because 1 take away 1 is 0, it means that the bottom number must be our remainder, and that means it's our remaining number. And then we're going to go ahead and write the answer, and then add R13 for the remainder, and then we're done. We'll go ahead and do that. So our answer is for 838 divided by 14 equals 59 remainder 12. It's horrible to see, I'm sorry. At this point, we're not going to talk about making the remainder either into a decimal or into a fraction. That will be for the next segment of the lesson, which will probably be the following day. I think it's just important to do one step at a time and to make sure the students really understand this. So we're going to be doing a few more problems like this on the overhead as a class. That way I can monitor their progress. Again, using the whiteboards, maybe make it into a competition. After which, after the teacher demonstration, I'm going to give the students 2 more practice problems while we're still seated on the floor. They can either do these alone using their whiteboard, or they can work with a partner or in groups of 3. Doesn't really matter. It's just a good time for me to assess their understanding and to really work with students individually who need help. After which they'll have to explain the process, how they solve this problem to the class. I'll call in a few students, preferably stronger students at this point. And that way I can also understand who to pair up, because the next part of the lesson, they're going to be working, if I can find my page, they're going to be working at their tables. And they're going to complete a set of practice problems in their table groups. They're going to have, these problems are going to be in their in the math curriculum that the school will have, which I don't have, but the school I worked at used Envision. So we'll probably give them some sets of problems from that. By sitting on the floor, I can also just work with kids individually, and use the area as kind of a way for me to give extra help. And then the last 8 to 10 minutes of class, they have math journals, and the students are going to complete a sample problem in their math journal, and then they're going to have to explain their thinking. Pretty much exactly what we did during the teacher-led demonstration. That's how I'm going to be assessing them, because I want them to understand the standard algorithm. They may be showing me how to solve the problem using other strategies, and that's still okay, but I'm going to ask them, like, I'm going to reiterate the importance of trying this method I taught them. And for their homework assignment, they are going to be given 5 practice problems, and they'll have to solve them using the standard algorithm with their parents. And that kind of is what goes into the, I guess, the family involvement section of the lesson. I apologize for just being kind of long and boring and not having any fun activities and children, but hopefully you get kind of a general idea of what my lesson will be about. And I assume the next lesson will be much more professionally done, I hope, and easier to follow. Thank you.